my friends, welcome to class. This is the New Horizons DP900 Azure Data Fundamentals webinar version, which means you get to hang out with me for an hour, and we're going to talk about the data fundamentals of implementing databases in Azure. Let me introduce myself. My name is Richard Morgan Jr. Guys, please call me Richie. All right, my dad's name is Richard. I get Junior, Little Rich. I got an aunt who calls me Little Richard. So I'll answer to anything, but Richie is what I prefer. I am a full-time instructor at New Horizons Computer Learning Center, stationed in my beautiful blue basement near Atlanta, Georgia. I've been teaching with New Horizons for a little over 24 years now. During that time frame, I've gotten a couple certifications, basically prove I'm a gigantic nerd, but hopefully they also prove I know a little bit about what I'm talking about. I am a Microsoft Certified Systems Engineer on Windows NT4 way back in the day. I am a Microsoft Certified Database Administrator, MCDBA, on SQL Server 6.5 all the way up to Azure Solutions. I am a Microsoft Certified Azure Associate, among other certifications. Basically prove, again, I'm a giant nerd. I have prepared a good bit of data-related fundamental information for Azure information for you guys today. However, we do have some, I would say, housekeeping elements to keep in mind. So let me put these up. Today, my friends, is official Girls' Night Out. National Day for Girls' Night. So just if you're a girl, be prepared to go out tonight. I'm just saying, you got to celebrate, right? It is official National White Chocolate Day. So, you know, put that in your lunch bucket. Got to get some white chocolate. Celebrate White Chocolate Day. I'm saying. It is also National Elephant Appreciation Day. So you don't want to miss out on thanking your nearby elephants. I have a big old German Shepherd. He's about as big as an elephant. But, yep, got to thank your elephants. And it is also National Hobbit Day. So make sure you have a mug of ale or wear some furry slipper feet. You know, National Hobbit Day. Celebrate being a hobbit. Whatever the case may be. Now that housekeeping is out of the way, what are we going to talk about? Now, normally, when this is a one-day course, we go through exploring the fundamentals of data. We talk a bit about some of the core concepts of databases, what they are, how they work, and how do they work in Azure. We will explore some of the fundamentals of relational data in an Azure platform, some of the various relational data concepts, and how does Azure address those concepts for relational data in Azure or in the cloud. We also talk a bit about some of the fundamentals of non-relational data in Azure. This is where they talk about some of the different non-relational needs or uses of our data and how to make use of that in the cloud. Specifically, they'll talk a bit about the Azure Cosmos database and what does the Azure Cosmos database offer for the non-relational needs. Then they also get into the fundamentals of various data analytics approaches. Large-scale data warehousing, talk a bit about streaming that data, real-time analytic type of elements for that data, as well as different data visualization. Specifically, they dive in the lab environment and have you guys play around with some Power BI, which is definitely worthwhile. In the one-day version of this class, there are a few points that we might throw some hands-on at you. But again, in a one-day something, yeah, we really don't have a whole lot of time. It's there. You can go to learn.microsoft.com, and they've got some hands-on elements available for you if you want to take a look at DP900. Let me throw that into the mix. https://learn.microsoft.com. And again, that's where they'll have the material and the hands-on elements, so you can actually practice and play around with this. For our 1 hour shot in the arm, hey, what is Azure Data Fundamentals? Richie's going to demonstrate. I'm going to show you guys some pretty cool stuff that is extremely worth your while. I think you guys might benefit from seeing some of these things. So I'm going to get out there and show some of that stuff off in Azure. Let you guys see that in action. So there is no lab environment for us, but again, if you do come and take the one-day class, there are likely some hands-on elements that we might share and do together. So what is this data fundamentals in Azure? What is it that they want us to talk a bit about? So I'm going to go ahead and open up their Module 1 content. It's going to need a little finagling, so pardon me for just a moment while I adjust and present. Fundamentals of data. Some things that they want us to be aware of when it comes to working with data in general and with a side eye off to the cloud. What are we talking about here? There are some core data concepts, some data roles and services that might be of interest to us. As far as core data concepts, well, what is data? Let's go ahead and lay that out there. What is data? Well, they say, Microsoft says, data is that values that are used to record information, often representing entities that have one or more attributes. That's a fair definition. That's a fair definition. I oftentimes say data is the lifeblood of your company. It is the core representation that you are doing business. If there's not new data coming in, you're likely not doing any business. We need to record certain things so we can keep track of who's receiving what services, who is receiving what products. These are things that are recorded. We also want to ensure that we can record this information for analysis later. It records our business information. Now, it's not always business. I mean, yes, I'm a giant nerd. We've established this already. So I have databases that I use to keep track of my daughter's sporting events. I have databases that I use to keep track of my Dungeons and Dragons dungeon mastering. I have databases that I use to keep track of personal projects. Yes, so it's not always business, but the business of you, whatever that business is. There are, as they illustrate here, 3 different ways that we might choose to organize our data. We can have a structured format for our data. A structured platform, a structured format for our data allows us to be able to organize that data, and then all of the additional data being recorded follows that same structure. This is oftentimes where we will see tables with columns and rows of data, and oftentimes they are related in some way. Now, we can also store our data in a semi-structured format. A semi-structured format is just like if you've got a notepad and you're writing down important notes about various aspects of your business. It doesn't have to have the same format every time, right? So for one customer, you might have a phone number and an address. For another customer, you might have 2 addresses. For another customer, you might have 3 phone numbers. Right? They're all customers, but they don't have matching data every time. In a semi-structured format, we can still have customer information, but it's not the same data every time. And then we also might have what is referred to as unstructured data. And I like to say unstructured data is data that doesn't know it's data. It's data, it's important, but it's data that doesn't know it's data. For instance, you may have an email, and inside of that email is a little bit of information about a possible customer. There's customer information in that email. In the body, someone's discussing, hey, you need to contact so-and-so at such and such a number, or send them a note at this address. It's in there, but this email doesn't know it's data. It's unstructured. And I may take the whole email and just put it off to the side. Represents data that I'll have to operate on later. You see, unstructured data is data that needs some help to become usable and worthwhile data. So unstructured data is oftentimes just stored, and it's data that doesn't know it's data yet. It'll become data, but we're not there yet. So how is that data stored? You'll find oftentimes that data shows up as a file of some sort. Maybe it's delimited text, right? We're all familiar with, if you've worked in databases at all, comma separated values, or CSV. It's a very simple, easy way to deliver data from product to product. It's a good middleman solution, like a JavaScript object notation solution. The difference is delimited text is structured. When you use delimited text, it has to have the same values separated by commas, row by row. Otherwise, stuff gets thrown off and you can't consume it. So it's structured. You've got first name, last name, email. First name, last name, email. First name, last name. It's the same stuff every time, row by row. With JavaScript object notation, we're doing what we refer to as key value pairs. And the interesting thing with JavaScript object notation, also referred to as JSON, is you don't have to have the same thing every time. You could have first name, last name, phone number, first name, last name, address, first name, last name, phone number, first name, last name, address, address, address. They're all customer data, but it doesn't have to be the same structure every time. So it's semi-structured. The same thing can be done with extensible markup language, also referred to as XML. XML was the, and it's funny, just as an aside, how fads come and go in databases. XML was the fad not more than about 3 to 5 years ago. Everybody wanted to use XML to transition data from point to point, to travel from point to point. It was a way you could serialize your data and be able to put it in a way to travel across the web. And now the fad is JSON. JSON has replaced XML. They're still both very functional, very effective. But JSON happens to be the data format du jour. It's the fad of the day. Everybody wants to store or transfer data utilizing JSON. Now, the binary large object, or blob storage, is still file storage, but it is that unstructured data I was talking about. It's data that doesn't know it's data. It doesn't know that there's important elements inside. It could be a Word document. Well, inside of that Word document, I have certain bits of it. It could be an image. It could be a video file. There could be important elements tucked away in an audio clip. And it's the binary object that has that information in it, but it doesn't know its information. It doesn't know its data until I find a way to decipher or interpret that content and draw out the important elements to put them in CSV, JSON, or XML. You might also have certain optimized formats for various databases, Avro, Orc, Parquet. Then various databases are going to have their own internal storage, but they're going to make sure that they store stuff so that there are relational tables, right? So we've got a customers table and a product table, and together the customer orders that product on a product order in the orders table. And we might even have line items bringing those together for a specific order with these multiple items being purchased. A relational database is going to hold tables with records that happen to be interrelated. It's going to have its own file format internally, of course, but it's going to store that data, and you will oftentimes interact with it utilizing applications or tools that communicate with that database using SQL, Structured Query Language. So you'll find that the databases are oftentimes easily interacted with. As long as you can establish a secure connection with an appropriate tool, you can then send a request to that database, get results back. Now, we also have databases that are non-relational. And again, non-relational database solutions don't store stuff in tables that have the same columns with rows and rows of repeated values going down. They don't oftentimes relate those values to each other, but they will still find a method of storage for data retrieval that works for that data, that works for that platform. We may have what is referred to as a key value setup, where I have a key and a value. And as long as I know the key, I can recall that appropriate value. I might have a document where the document is the data, and I will decipher that document each time I need to interact with it to retrieve a given bit of data. We might actually have what is referred to as a column family data solution. With a column family data solution, there will be a key, and then that key will be associated with various columns so that I could bring it all together in the end if I needed to. This allows for optimized storage and speedy retrieval in certain cases, depending upon how you build or bake that up. You may also find what is referred to as a graph database. And graph databases are optimized for relations between what they refer to as nodes and networks, or nodes and relations. In the example they show here, Ben and Sue are both employees, but Ben reports to Sue. And Sue works in the hardware department. So does Ben, works in the hardware department. But you can identify those relationships between those individual nodes and how they are interrelated. A graph database keeps up with that and makes it easier to report, especially when it comes to like organizational charts and that kind of thing. Graph databases are grand with that type of relation. Now, what oftentimes we're going to find is that interaction with our data, if we're not careful, could lead to inconsistency in our data. So oftentimes interaction with our data, with our databases, we're going to want to make sure that we effectively make that transactional, where we identify, hey, I'm about to do something with my data. Get ready. Okay, let's do this, let's do this, let's do this. And then when we're done, let's commit that. The idea is that oftentimes interacting with your data requires 2 or 3 steps that have to succeed together or not at all. Your changes must succeed together or not at all, because if one of them succeeds and the other ones fail, you leave your data in an inconsistent state. For instance, let's say that you're a saver, okay? Every Friday, you transfer $100 from your checking account to your savings account. You're a saver. That requires 2 update statements in a database. Update checking, set your balance minus 100. Update savings, set your balance plus 100. Yeah, that makes sense. Let's say that the update to checking succeeds, minus 100. But the update to savings fails. Where's your $100? If both of those 2 statements don't succeed, you're out $100. All right, well, let's go the other way. Let's say the update to checking fails, but the update to savings succeeds. Well, the bank's not going to be happy now. Your savings account has an extra $100 that didn't come from your checking account. Where did it come from? We can't report that. That's problematic. I don't mind it, but the bank is unhappy. We must succeed on both statements or not at all. I am not going to be happy. I'm not going to be able to function well in a database where parts of my changes are disappearing every other time. So we have to make sure that we are encapsulating those changes. This is what we refer to as transactional data workloads. We have to tell the database, begin a transaction, update checking, update savings, commit the transaction. Now, if I begin the transaction and the 2 updates succeed, I will commit the transaction and I'll tell the database, hey, I'm done. My work is finished. I did consistent work. On the other hand, if I begin a transaction and the update to checking succeeds, but the update to savings fails, I need to hop out of that transaction and go to an extra line that says roll back. And when roll back is issued, the completed piece gets undone. because the other piece failed, the completed piece needs to be undone. I don't want the first half to succeed if the second half doesn't also succeed. This is referred to as atomicity. I have to ensure that all the parts of my change occur. You can't split them. You can't break them down any further. It is like an atom of an element. If you break it down any further, it's no longer that element. It's no longer that work. If I take all the steps out and get down to the core of that change, update checking, update savings, you can't go any further. You can't break it down any further. You can't stop at the update checking. You're not complete. So atomicity is identifying the pieces that go together. Consistency means that when they both succeed, I have consistent data. I need to make sure they both succeed. So I will isolate them from everyone else. Isolation in this is going to ensure that my transaction does not get interfered with by anybody else. I begin my transaction, I lock these resources so no one else can get in. I will make my changes, and then I will unlock those resources when I'm done. And at the end of the day, if all is done properly, that transaction is durable. It exists. It is present. And it is recorded and recoverable if need be. For instance, I want to make sure that I'm logging these transactions so that if the server ever takes a nosedive, when we come back online, I read that log, there's my transaction replayable back into the data. So this is some good stuff. We might also have analytical data workloads. Analytical data workloads are where we're just going to be reading the data. We're not changing anything. We're not changing anything, but I want to take that data and I want to organize it and I want to calculate on it and I want to summarize it and I want to generate. Here's the way I put it, crew. If you're an analyst, if you are a data analyst, your job is to tell the story of your business, the story of its success or the story of its failures. Your job is to tell the story. The data is the facts of the story. And if you just share the facts, things can get boring. If you dress it up with graphs and charts and diagrams, colors, well, now as an analyst, you help that stuff sink in better. You help the impact be made better. Your job as an analyst is to tell a story, not just to put a chart out there. Let's tell a story of the business. So analysis of that data may need to be done. Generate summaries, understand over time, lay it out over time. Let's understand the transition from good to bad. I mean, that's analytical data workloads. You've got to do those. They also bring up some interesting elements about who does these jobs. The professionals who are going to be responsible for working with this data. Maybe you are the database administrator. Your job as the database administrator is to keep that data alive. Don't let it die. Don't let it get deleted. Don't let it get corrupted. Keep that data alive. As a database administrator, you are responsible for ensuring the security of that data, keeping the wrong people out, allowing only the right people in. But you want to most importantly keep it alive. Resilient, performant data. Now, a data engineer is oftentimes the person who's going to be responsible for taking that data from where it lands and deliver that data to where we can analyze it. Clean it up, organize it, transform it so that the analysts can do their job most appropriately. The analysts, like I said, their job is to tell a story. They will do the appropriate modeling, summarizing, visualizing, and reporting of that content to tell the story of the performance of that business, good or bad, one way or the other, to relate what the details of that data actually say, right? To roll the bones and understand what's going on inside the business. Now, Microsoft comes to this game and says, hey, whether you're the database administrator, the database engineer, the data analyst, the data scientist, whatever you are, here's what Microsoft offers to be able to support you in the cloud. They've got quite a bit of cloud-related information. I mean, look at here. We've got several options of what the data provides, or what SQL Server provides, what elements of the items provide. India, if you want a picture of the previous slide, here you go. Take a screenshot. Yeah. Windows key Shift S, I believe it is the Windows snipping tool that you can use at the moment. So get that picture. 5, 4, 3, 2, 1. Okay, let's go. What does Microsoft offer? In the cloud, we have the ability to host your data, but it's not just hosting your data. We also offer engineering and analytic tools for being able to move data, cleanse data, transform data, and of course to present that story, to tell the story of that data with stuff like Power BI. Do that analysis up there. So they've got several options for being able to hold, manipulate, and analyze that content. So let's get into it, shall we? If I wanted to utilize relational data, structured data in the cloud, what is it that Microsoft offers that I can use for my structural relational data needs? So we've got several options in the cloud for that, depending upon how you want to put that together. How do you want to put that together? Microsoft says, hey, if you want to put that together with only Microsoft SQL Server data, maybe you already have Microsoft SQL Server data, maybe you are creating a solution that will exist at the Microsoft SQL Server data in Microsoft SQL Server data, and you want to do it in the cloud, Microsoft says, hey, if you want to go with Microsoft SQL Server data, which is an excellent choice for relational data storage, tables that have columns and rows, we've got you covered. We have you covered for putting your content in the cloud for relational storage. In the cloud, Microsoft says, hey, yeah, your relational tables, standard table with columns and rows, is going to be storable after you build the best possible relational database, following the steps of normalization, generating interaction with the structured query language. I mean, there's all sorts of elements that go along with that. What are we going to create otherwise in the database? Well, we might have views and stored procedures and indexes in our database. But in Azure, we've got 3 possible SQL Server solutions that we could make use of. 1, you can implement an Azure SQL database. An Azure SQL database is a database in the cloud. Just a database. You don't have to manage Windows. You don't have to manage updates or patches. You don't have to manage anything but your database. Your tables with columns and rows, your relationships, your views and triggers and stored procedures, everything that goes into making a database, that's all you have to worry about. It's a database in the cloud. Now, because it's just a database, it comes with some restrictions. Okay, there are some things that if you were to implement this in your own SQL Server on premises, you could do. You could do a full database backup. We can't do that in an Azure SQL database. You could do inter-database querying. You can't do that with Azure SQL database. It is its own island of data. You can interact with it with your applications, web applications, desktop applications, whatever. You just give it the appropriate path to the database, but it has to be its own island. You can't go outside of this database to get any other data. It's the core database functionality. Now, of note, it is evergreen. And what that means is it is always the newest version of SQL Server. The newest version with the newest features, always evergreen, which means you don't have to choose what version of SQL Server you're running this on. It is an evergreen solution. Now, I'll go even further just so I can lay this out here for us. This is evergreen, and so is the Azure SQL Managed Instance, by the way. That doesn't help. This box doesn't allow for changing color. There. All right, so both of these are evergreen. But again, always the newest version. Always the newest version. Well, what if I require a certain feature set from an older version of SQL Server? Well, that's when you need to develop your database utilizing what is called compatibility mode. Microsoft SQL Server has a feature called compatibility mode, where you can say for a given database, I want you to operate as if you were on SQL Server 2014. That's called compatibility mode, which is kind of cool. So even though we are always the newest version of SQL Server with the newest features and capabilities, we can also regress a database with compatibility mode to make it behave as if it were an older version with older features and behaviors. So evergreen is cool, but we do have some control over what support is necessary for our database if we need to. Azure SQL Database is just the database. Now, what if I need 2 or 3 databases to operate together? What if I need some management and administration, some jobs and alerts and operators that I want, but I still don't want to manage the operating system. I don't want to manage the patches. I want to be on the most recent version of SQL Server ever, the evergreen kind of idea. Well, that's Microsoft's Azure SQL Managed Instance solution. A managed instance gives you a full SQL Server instance install and all of its features, but you don't have to manage the operating system. You don't have to manage the updates. You don't have to manage the patches. You don't have to manage any of the additional software on the side. But again, you're restricted from managing additional sidecar software. You can't install any additional elements, right? It's just the server and all the databases that you may want or need. This comes with the same features that Azure SQL Database comes with, automatic backup, so you can't do them to a degree. With a managed instance, you can do copy-only database backups if you needed to. But this allows you to have multiple databases that are tied together within a single application, which you can't do with Azure SQL Database. This allows you to be able to have an instance of the SQL Server that gives you near 100% compatibility. 99.999% compatibility with whatever you have on premises without having to manage the underlying Windows or a virtual machine. Again, it is also evergreen, so it's always the most recent edition of SQL Server, the most recent version of SQL Server, always and forever. Even when a new one comes out, they immediately update to it. And again, if you have specific needs for a given database, you need to make sure you're using compatibility mode to lock in for that database that specific behavior, because both of these solutions are evergreen. Now, let's say that evergreen ain't going to cut it. Compatibility mode isn't the solution for your database, and you have to have a SQL Server 2014. And you want to manage the operating system so that you can do some registry edits and add an additional bit of software beside the SQL Server. Well, that's when we may need to step back and take a look at implementing an Azure virtual machine with SQL Server installed on it. An Azure virtual machine can have any software you want installed on it, including SQL Server 2014, as long as it's legally licensed You can install whatever software you want on your Azure VMs. You manage the virtual network. You manage the storage. You manage the virtual machines updates, patches, and service packs. You manage all the software on that virtual machine and their software updates, cumulative updates, and service packs, whatever. Now, of note, this oftentimes then comes with a much higher price tag than the possibility of implementing an Azure SQL database or an Azure SQL managed instance. Again, the cost of these is usually commensurate with the actual work that's getting done, but also the amount of work that you're kind of giving up, depending upon what you're after. But generally, the VM is going to be more costly because it's more capable. The Azure SQL Managed Instance is a little less costly, but it still can be costly depending upon what you are consuming. And the Azure SQL Database is going to be the cheapest because it has the least functionality, but it's the core basic database hosted in the cloud functionality. You'll oftentimes see Azure SQL Database recommended for any brand new cloud-based applications as well. It's a super simple, easy way to put data and an app in the cloud together. But if you are working with a Microsoft SQL Server need, 3 possible solutions to fit your need. A full-on virtual machine with a database server installed in it, just the database server with a managed instance, or just the database. I don't need multiple other databases. I don't need all these extra features. I just need data in the cloud. Azure SQL Database, they've got you. Now, what if I wanted to be able to interact with something not Microsoft SQL Server? Well, we do have open source database support as well. So Azure says, hey, if you've got MySQL database needs, or MariaDB database needs, or PostgreSQL database needs, we have you covered. We got you covered for your open source database needs. And we will bring with that, again, this is a service solution. You don't have to manage the Linux underneath these guys. You don't have to manage the patching and the service packing of the software itself. You put your database into their hands, and they will help you manage it and maintain it and provide access to it. But all the underlying grunt work, they take care of it. As a platform, these are the database as a service solution for your MySQL, MariaDB, or PostgreSQL needs. The application then of, well, what if I've got databases that, what if I've got data that doesn't fit with the whole relational idea? I don't have tables and rows with columns of content. I've got some more non-relational needs. I got something that doesn't fit within your relational table needs. I need something that's big data. We have big data. Everybody has big data. So where do we go with that? With our big data solutions. And this is where we're going to find non-relational, unstructured solutions need to come into play. So Microsoft has for us some non-structured, non-relational options that might provide your solutions in the cloud, in Azure, of course, here. What are our non-relational, unstructured data options? So the first thing they want to bring up in this conversation is, well, if it's not structured data, right? It's not relational, structured tables with columns and rows. You got to store it somewhere. It starts as a file somewhere, somehow, right? So we've got to store it somewhere. Let's talk about Azure Storage. Azure Storage comes to us in a couple of different varieties. When we talk about Azure Storage, we're going to talk about the fact that we've got blob storage. This is oftentimes a popular type of storage for non-relational data, for unstructured data, blob storage in Azure. And blob storage, there are a few options to select when you're setting up or configuring blob storage. There are block blobs, there are page blobs, there are append blobs. And the basic idea is not necessarily what you're storing, but how will your application interact with it? That's the decision. It's not what we're storing. It's how does my application want to interact with it? When we're talking about blob storage, we're talking about an application that wants to interact with the data a piece at a time. I don't need the whole file. I need an 8K block, an 8K block, an 8K block. My application is going to interact with that data a piece at a time, portions of the data at a time. And so blob storage provides that. Block blob allows for large discrete binary objects that change infrequently, right? A video, an audio clip doesn't change that option. They can be up to 4 terabytes in size, but we operate on them in blocks of up to 100 megabytes apiece. Up to 100 megabytes. We operate on them blocks at a time. Now, page blobs are those types of blobs where the data may regularly change. And I need to work with this data, I need to work with that data, I need to work with that. And again, it's not 100 megabytes, but it's 512 byte pages, tiny little pages that I'm going to be reading and writing to regularly throughout this blob. I mean, think about it, crew. Whenever I'm working with a Word document, I'm not working with a piece of the document, right? I'm working with the whole document. I have to have the whole file when I'm working with Word. Word is not what we're talking about here. Excel is not what we're talking about here. What we're talking about here is stuff like Microsoft SQL Server operates on data, not the whole file, but 8 kilobyte pages at a time, or 512 byte pages at a time, okay? We operate a piece of the data at a time. Blob storage is for that type of data interaction. Append blobs are great for logging solutions, where I am going to log activity, and all I'm doing is I'm adding new stuff to the bottom of a file. I don't edit or manipulate what's going on up top. I just add stuff to the bottom every time. New data, new data, new data, new data, always at the bottom. That's an append blob. And again, logging applications are great with append blobs. When we implement blob storage in Azure, we can choose to store it on very fast disks, on fast disks, and on slow disks. We have options for the type of disk that we want to store our content on. Now, you're not really choosing the physical disk, but you want performance at this level. Or you're okay with performance at this level, as long as it costs less, which usually it does. When we choose our storage tier for blob storage, we are implying that I want the fastest speed, and I'm okay with a higher cost. That's hot tier storage. Or if I go with a cool tier storage, I am looking for a middle ground. I am not necessarily the slowest, but not necessarily the most expensive either, right? I want kind of a middle tier, lower cost option. And then if I'm okay with just slow as old PCs slow, put it off to the side, and that's the lowest cost alternative for storing, highest latency. And I'm talking, when you choose archive tier, that is hours of latency, not a joke. You put your data into the archive tier, retrieving that data could take hours of retrieval time. And the way I think of archive tier is, if this is the hot tier, solid state drive, and if this is the cool tier, platter-based drives, then archive tier is tapes. And I don't have a tape to hold up, but archive tier is a tape drive. where you have a little robot in a library, and the robot finds the appropriate tape and pulls it and plugs it into the drive. We load our data onto it, so it's pulling the tape through and throwing bits at the magnetic strip, and then we eject that tape, and the robot takes it and finds the little hole in the library and sticks it in there. And then he's got a queue of data that is being retrieved, so he has to find the right tape, pull that out, plug it in, and you, if you want to get your data back, go into that queue. And eventually, we'll have a little robot hand find your data, pull it out, plug it in. Hours later. So again, archived here is definitely long-term storage. Here's the thing I need you to catch about blob storage, though. Blob storage, by default, is one layer deep. We don't have folders and directories in blob storage. It is one layer deep. It is a flat namespace. And you may name a set of files or a file with a folder name in the name, but you're not tricking anybody. It's still just blob2 that happens to have the folder 1 as part of its name. It's a single layer. We don't have directories. We don't have a hierarchy here. Use alphabetization to keep certain things together by naming them as if they had a folder in their name. That's all you're really doing, is putting a folder in their name. It's still just a single layer. There are no folders. It's still just a single layer, a single flat namespace when you're storing blobs. So it can get messy. It can get difficult to understand. Stuff can get difficult to work with. Blobs can be organized in virtual directories, but again, the path is considered a single blob in a flat namespace. The folder name is just an additional name to the file. That's all it really is, an alphabetical organization. Now, so there's room to improve blob, right? Blob is a single flat namespace. What if we were to make use of... Well, let me back off for a second and give you a bit more motivation to understand this topic. You see, oftentimes if I have big data, because everybody's got big data, right? If I have a single big file, that means if I am going to consume that data for analysis purposes, that single file is going to be consumed by a single process. A single process on a single processor on a single PC. If it's a single file, that one file is connected to that processor, that process, and I am going to have humongous amounts of data being managed and manipulated and analyzed by a single process. And it's going to take forever. It's going to take forever, right? What if I could invite some other processors in to help me process this? Well, in order to do that, I'm going to have to take that single file and bust it up into multiple smaller files. Okay? Multiple smaller files. But we want to do this with some logic, with some organization and understanding to it, right? So what if we look at the big data in this one big file, and we identify some context within that data for separating out portions of that file into multiple subfiles? We identify some context. Maybe it is by date, by year, by quarter, by month, by week. What if we identify some context in that data and we create a directory hierarchy to represent that context? And now, instead of one giant file that can only be interacted with one process on one processor on one PC, now I've got an organizational masterpiece of contextual directories that appropriately reflect content from the data for organizing multiple files, and I can sick a whole cluster of servers on that data, all operating together like little bees, like little ants, all each operating in their own little hierarchical namespace area. That, my friends, is data lake. Data lake is a riff on blob storage. It's still blob storage. Binary large object storage, we're going to operate on pieces of a file. But here's the thing, we take the file, one big file, and we chop it up into multiple smaller pieces and organize them by some context of the data inside. We have a hierarchy of folders where we have year as the top level, and then quarter as a subdirectory, and then month as a subdirectory, and then week as a subdirectory, and then day as a sub. And this way, we can organize the big data in smaller chunks that can then be consumed by a cluster of servers. And they can all participate in helping to do the analysis and processing that data into a cube, right? A tabular cube, a multidimensional cube, processing those summary values so that we can then report on some analysis of that content, do some modeling on that content. Again, data lake organizes that data in such a way that it's more easily consumed by a group of servers instead of a single server doing the job. That's one of the primary purposes of data lake, and one of the main differences between standard blob storage and data lake storage. Standard blob is a single namespace, flat single namespace. Data lake is blob with directories. Blob with directories. I mean, it can do some cool stuff. Now, of course, we also have Azure file storage for folks who operate with applications that use regular files. This is not big data storage, really. It could be. If you get a file from somebody, you can put it into file storage. But really what we want that file in is a blob or a data lake. We also have table storage. Again, very useful for other applications if we wanted to be able to do table storage. Key thing to remember, and their illustration is crap for this. When you use Azure Table Storage, it is 2 columns. It is 2 columns. Column 1 and column 2. Okay? It looks like this has got 5 columns. It's not. It's 2 columns. Column 1 is a key made up of a partition value and a row value. It's 1 column made up of 2 values glued together. And then the value column, which can be made up of whatever you want to make it up of. It can be different for every row that comes in. So in truth, your Azure Table Storage is actually 2 columns. The key and the value. The key and the value, that's it. It's 2 columns. That value could be made up of comma-separated whatever that represents multiple other items inside, but that's up to your application to define and interact with. Also of note, Azure Table Storage does not respond to SQL. You don't establish an SQL connection to these guys. They've got a set of functions that you use to interact with this guy. So it's not like a standard table that you would find in a SQL Server or a MySQL server or a PostgreSQL server. You don't interact with this guy using SQL. You have a block of functions that you call upon to interact with this stuff. Specify a key, get a value, and then decipher that value however you need to pull it apart. Commas, colons, curly braces, parentheses, whatever that value is made up of, you pull it apart. But it really is just 2 columns. Key and value. Keep that in mind. So, here comes the king of big data solutions. Microsoft offers to you a database platform for unstructured data, for binary large object, data lake storage data. Azure Cosmos DB brings that big data management solution Here's what it really brings, though. There are two key features for Azure Cosmos DB. It is flexible. Number one, you can swap out its engine type for different types of data that you anticipate interacting. Azure Cosmos DB is flexible above all things. Secondly, it is distributed. Azure Cosmos DB is flexible and it is distributed. Now, what does the distributed mean? Well, it means that you can actually have Cosmos DB in the East US, Cosmos DB in the European market, and it is a synchronized copy of data between the two. Users in the US can all communicate quickly with low latency with their local East US copy. Users in Europe can communicate with that copy up there in Europe quickly and effectively with low latency, but it is the same data. It is a distributed database. That's Cosmos DB. Now, what are we talking about flexible? What's the engine change? Well, Cosmos DB can interact with document data, graph data, key value data, column family data. You can swap out your Cosmos DB API for whatever type of data it's required to interact with. We have an Azure Cosmos DB for NoSQL API. This is the native API, standard API for Cosmos. It allows for SQL interaction and it stores the data as JSON. Cosmos DB for MongoDB, again, operates on MongoDB stored content, oftentimes Avro or Orc stored data. Note that you don't interact with MongoDB using SQL. It's got a bucket load of functions, so Cosmos DB supports that type of interaction. Azure Cosmos DB for PostgreSQL, all right, Parquet files. Postgre likes to store stuff as Parquet, so we will have Azure Cosmos DB offer that type of solution for big data stored in Parquet files. Table API, which again is really just key and value, two columns. It's fast because of that, just those two columns. You supply the key, we go and grab the value and bring it back. Again, not SQL compliant. We also have Cassandra storage. Compatibility with the Apache Cassandra, which is a distributed database solution the Apache team has come up with. We support interactions with those types of data, as well as what they call Apache Gremlin, which is graph data. So we support all sorts of graph data interactions here as well. Some good stuff. But again, this is Cosmos DB. One of Cosmos DB's biggest benefits is its flexibility. The other main benefit of Cosmos DB is its distribution, being able to synchronize content across the globe. You can have Cosmos DB offered in England, you can have Cosmos DB offered in New York, you can have Cosmos DB offered in LA, and then synchronize content across at whatever speed you require. At whatever speed you require. And again, Microsoft, because they are global with Azure, can support your interactions in those areas wherever you need to go. Gang, I know that we only have an hour together. I appreciate you guys' attention and hanging out with me, asking appropriate questions and interacting. That's all I have time to cover. Come back for the full day. I would love to have you guys in our DP 900 full day class with some actual hands-on demonstrations, talking about this kind of stuff. My friend Brandon wants to talk to you guys a little bit more about what New Horizons offers. So we'll let Brandon take over at the moment. It's been my pleasure to be your guide. Have a wonderful afternoon, my friends.
Well, thank you so much, Richie. I already see tons of hearts and applauses. If we can keep those going, put them in the chat. Just thank Richie for everything that he's been able to discuss today. We are so grateful for him. As always, just thank you so much for coming today. I know it's a Friday and everyone is ready for the weekend. So thank you so much for joining us for this New Horizons webinar. As always, once you leave today's webinar, you are going to get a one-question survey asking if you would like to continue the conversation. That just simply means if you've enjoyed what you've been learning today and you're like, you know what, I want to learn more about this, maybe join a class or whatever it may be, or you're like, you know what, this is all good, but I could use some help in knowing how New Horizons can help me in my personal professional development. Go ahead and say yes to that question. We'll get you connected with the right people to be able to have those discussions. So, as always, you're welcome to follow us on LinkedIn. You'll see updates on what's going on with New Horizons, what future events we have, all of that stuff. So, thank you all so much for coming today, and have a wonderful rest of your day and a wonderful weekend.